protocol. And the difference between the TCP and UDP is just the connection. Okay, so network. Okay, so so we looked at NIC information, we looked at media, we looked at topology, protocol. Now let's work upon IP address. Okay, so I'll touch a little base about what IP address is so that you have some good understanding. So IP address is internet protocol, and address is a numerical label assigned to each device connected to it. So IP address is essentially a phone number. Okay, so if you are Burhan, you have an IP address, right, which is your phone number. Okay, that's all there's to it. And so let's look at our IP address, which is so I'm logged into a system here. If I clear this and if I do IPA, I have this IP address here, right? So let's worry about the local IP address here. I'm gonna exit out of this. Okay, no. So here's my IP address here. We see 192.168 56.108. Okay, so we're gonna concentrate and decode this IP address here, what it really means. So in computer world, it works only on zeros and ones. Okay, computers works in binary, right? On binary system. okay, it can only recognize 2 digits. Okay, which is called base 2. And base 2 is only 2 digits, which is 0 equals 0, 1 equals number 1. Okay, 0 also means off and 1 also means on. Okay, so let's see how this works here. So let's take a look at binary. So if you look at the picture for binary here, right? So this is exactly what it looks like. This is a binary code. So no matter what you're writing on your system here, deep down on the hard drive level, when the system is writing to the hard drive, it's writing the binary code here, okay? Okay, good. So now, based on this binary code, our IP address is based on 32 bit. 32 bits. 32 bit. So 32 bit structure, which come out to 8 octets. Okay, and information is written in binary. So it's written in zeros and one. Okay, so let's take a look here what it means here. So if you do 2 to the power of 8, no, 2 to the power of 7, I think, yeah, is gonna equal 128. It's gonna equal 100 and let's do a math here. Okay, so we have 8 positions here, right? 8 octets, that means 8 positions. So let's see here, octet. So it's gonna say decimal and binary, right? So 8 octets. Octets is 8 bits actually, I'm sorry. 1, 2, 3, 4, 5, 6, 7, 8. 8 bits, 32 bits, so 2 to the power of 8. So how is this being calculated? Let's see here, octet. So octet means octet.
So 8 is 1 octet, 32 is 4.
Yeah. So this is really good. So hold on. Too many tabs open here. I'm gonna close this. Close this. Close this. Close this. This. So let's see here. So what we have here is 8 octet means 5, 6, 7, 8. So we have 8 boxes here, right? 1, 2, 3, 4, 5, 6, 7, 8. So if it's one box, so one box is a bit, the lowest you could go, okay? And then the next one up is 4 bits. So if you have this here, let's see here. 1 is, and then if you merge this, so 1 is 1 bit, and 4 bit is nimble. Nibble. Is it nibble or nimble? I thought it was nimble. Nimble. Okay, I may be wrong here. So it's nibble. Nibble, right? Nibble. Nibble is like the second smallest. Bit is the smallest. Nibble is the second smallest here. So we'll come back to that in a minute here. So 4 bits is so I'm gonna go up, merge, insert above. So we have 8 here, okay? So out of 8, if you have like 1 is 1 bit, okay? And if you have 4 in there, so let me delete this. Let me delete this part here.
Is it possible to make the screen a little bit bigger, the text?
Yeah. Does it look good?
Oh, very good.
Okay. um, come on, the screen is frozen. Okay, one of them is, and if it's a pack of 4, then it's nimble. Okay, and when it's pack of 8, then it is a octet. That means it's got 8 in it. So this is called octet. So this is a 8 octet. 8 bits equals it's called octet because 8 is octet represents 8, and this is where it equals 1 byte. Okay, and then so what happens here is where is my calculator? So if I do, everything is based out of 2 here, right? If I do 2 to the power of, if I multiply 2 to the power of 0, the answer will be 1, right? No, not multiply, but 2 to the power of, let's see here if I have scientific. Okay, 2 where is the caret function? Okay, it's not that power. If you raise 2, it's already. Okay, if you raise 2 to the power of 0, answer will be 1. Okay, so here 2 to the power of 0, answer will be 1. Okay, and now if you do 2 to the power of 2 to the power, okay, now not that. Okay, so 2 to the power of, let me clear this again, 2 to the power of, okay, it won't clear. Okay, now it does. 2 to the power of 0, right? If you do 2 to the power of 1, then it's 2. 2 to the power of 1 equals 2. Okay, so this is where we have now, and then 2 to the power of 2 is how much? 2 multiplies 2 times is equal to 4. Okay, and 2 to the power of 3 is gonna be 8, right? So this is 2 to the power of 2 to the power of, why am I getting that? 2 to the power of 2. Okay, this is where it is. And the 2 to the power of 3 is 8. Okay, everybody good so far, right? And this is what it is. And this one is also 2 to the power of 0. 2 to the power of 0 is 1. It looks bad, but I'm gonna shrink the, okay, yeah, that should be good enough. Okay, now, so this is how it's gonna be going up here. So the IP address is a 32-bit. So 2 to the power of 8 becomes 1 octet here, okay? So you have 1, 2, 3, 4, 5, 6, 7, 8. Either you have zeros in there or you have ones in there, okay? This will become 1 byte. Now we are to the byte here, byte level. So if I do a Google search here, 1 byte, we kind of have the answer over here. Binary digit, 8 bits. Okay, I kind of like this here. So we normally don't worry about the nimble part, but we worry about starting from 1 kilobyte, 1 byte. Okay, so by the time you get to 1 kilobyte, so 1 kilobyte is, so 2 to the power of, so 2 to the power of 8, 9. Okay, so 2 to the power of 10 is 1 kilobyte. Okay, 2 to the power of 10 is 1024. Okay, so here we're gonna kind of stop here. and here, so if you do 2 to the power of 10 equals 1024. Okay, so equals 1 byte. Okay, and this one is equal 1 kilobyte. Kilobyte means it has reached the 1000th place. 1 kilobyte. Kilo means 1000. One B. Okay, so it's represent 1 byte. So the next level up is megabyte. So thousands of byte is 1 megabyte. So what is the 1000th place? If you multiply this 1000 times, what will be, how many times you have to go up here? I think 2 to the power of 20 is it's moving into the position of 20s here. So let's see here. Okay, so 1024, if you do clear, 2 to the power of 20 is, look at this number here, 204876 number. So this is kilobyte. Uh, 1024 and 1048. Let's see here if it's 2 to the power of 19. No. So 1 megabytes is so 2 to the power of 20 equals, I'm going to put it in Google, 2 to the power of 20 is giving me 1048.56. I thought it was 19. So it doesn't make sense here. So 1 MB. When MB is 1000 bytes. So how many 1000 bytes, right? Now 1 MB is 1 million bytes. So how many kilobytes is 1 MB? 1 MB is 1000 kilobytes. So if you multiply 1024 times 1000, okay, those are the ones is kilobytes here. So 1024 times 1000. Okay, so 1024 bytes here. So this time here is actually 82 to the power of 82 to the power of 8 to the power of 8, I think. So let's see. No, that's too big. 8 to the power of 4. 8 to the power of 3, I think, yeah. no, 1024. Eight to the power of it's going to give you 4 kilobytes. So 1024 times 1000. So 1024 times 1000 equals 1024 equals a megabyte. 1 MB. Okay, 1000 of 1 KB is no, this is 1024. Guys, give me 1 second here. 2 to the power of 10. 2 to the power of 10 is 1024. So the 32-bit is okay, so that's a little confusing here. Okay, so let's see here. So all this is happening here is going to the multiples of 1000 here. So you start with binary and bits. So when it comes to IP address, it's going to be calculated in bits, not kilobytes and all that. So we have either 32-bit or we have 8 bits, or we have 32 bits, or we have 64-bit. So the IP address is based on 8 bits. Let's confirm that here. IP address. IP address bits. IP address is an address. The address is made up of 32 binary bits, which can be divisible by, so 1 octet is 4 bits here. So actually it is actually called binary bits. So this part, well, I'll come back to it when we need to. Okay, so for now I'm not going to worry about this. Here's, so we have, so far we have 8 here, right? So now what's going to happen here is, based on 8, we have 4 of these here. So how would it look like? The 32-bit is, let's see here. So I'll copy my IP address here. It says each octet is 32-bit, right? So here I'll copy, make an indent here, and okay, so this is 8 bits, 8 bits, 8 bits, 8 bits. So total 32 bits. Total equals 32 bit. Okay, so let's focus on the single bit here. So within 8 bits, there are 8 positions here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so let's see here how this is working. So what I'm going to do is I'm going to create another table here. So I'm gonna go, how many tables I need? 8, 5, 6, 7, 8. Okay, so the first is, so this is 8, 7, 6, 5, 4, 3, 2, 1. Okay, but first position is going to be 0. Okay, so the numbers, I don't care what it is, the number starts from right to left. I'll tell you in a minute why numbers start from right to left. So 1, then this is a second position, and this is a third position, and this is a fourth position, and this is a fifth position, this is a sixth, and this is 7th. Okay, so what is happening here is, so here, so if you do if you do 2 to the power of 0 here, the answer will be 1. Okay, and if you do 2 to the power of 1, the answer will be 2. And if you do 2 to the power of 2, the answer will be 4. So on. 2 to the power of 3 is the answer is going to be, what is the answer going to be? It's not going to be 6, it's going to be 8. 2 times 2 times 2, 3 times is going to be 8. Similarly, 2 to the power of 4. So the answer, what will be the answer? It's keep doubling. So answer will be 16. 2 to the power of 5. The answer will be 32. 2 to the power of 6. The answer will be 64. And if you do 2 to the power of 7, the answer will be 128. Okay, this is for IP address. This is where we're gonna stop. So now, so we have 8. So now what we have to deal with is, so each of them is a 32 bits here. So we're gonna have to find the position 0 or 1 in this bit here. So let's calculate our 192. What is our 192? This IP address we're gonna calculate in binary. Okay, so now what I'm gonna do is this part, you don't have, in real world scenario, you don't really have to worry about this here. So we need to find out what is 192. Okay, so we are not done yet. So let's copy this. Let's copy this here, and then I'm going to throw it in here. Before that, let me try to shrink this. Okay. So now what I'm going to do is, this is going to be our formula here. So we'll take 192 here, right? So I'll put 192. 192. So I'm going to see one out of 192. Can I subtract 128? I'm doing a subtraction in 192 minus 128. Okay, so how much is left? How much is left? 64 is left. So 64 is gonna go into a different box here. So since I'm able to subtract 192 from 128, I'm gonna put this switch on. So this switch is on. Now 64 minus 64, I'm able to do the subtraction, yes. So how much is left? 0 is left, right? So 0 is left. Since I'm able to turn on this switch, this is on. Okay, so I'm not able to subtract 0. I'm not able to subtract 32 from 0. So this will become 0. So 0 is going to carry over rest of the places here. 0, 0, 0, 0. So I'm not able to subtract 0. I'm not able to subtract anything out of 0. I'm not able to subtract 32 out of 0. So this is going to remain 0 here. Same thing with 16. Okay, since I'm not able to do that, I'm not worried about going into integer like minus 1 or minus 16. I'm not worried about that. So just 0 here. I'm not able to delete 8 out of it. So this part will become 0. All right. In reality, you cannot subtract anything out of 0, right? You can't. 2 is left here. So there is no way you could do this. And 1 is 0 here. So if you, when the computer writes on the hard drives, 192 is written like this: 00, 0 followed by 6 zeros. Okay, but it's going from left to right here. So the 0 starts from 0, 1, 2, 0, 0, 0, 0, 0, 1, 1. So it's going from system writes that it's going from right to left. So the English language goes from left to right, right? But the real numbers, they're going from right to left. Why are they going right to left? Is because what is 0 to 9? What is that? Can you guys, do you know what is 0 to 9 is what?
Single digit?
No, 0, 0, 1, 2, 3, 4, up until 9. So here, if you type number, right, so if you look at the image of number starts from 0, 1, 2, 3, 4, 5 here. Okay. Now, so 0 to 9 is numbers here. Okay, so what will happen if you type, let's see, just numbers. Okay, so numbers are written 0, 1, 2, 3, 4 here. These numbers is actually, the way the numbers are written are Arabic numbers, right? If you type Arabic numbers, it will give you the same results here. Starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Guys, you got to remember the numbers are Arabic numbers here, because when this is for our visual here, but in reality, Arabic is written from right to left, right? 0 starts from right to left here. That's why the computer system, since it reads Arabic number, is starting from right to left. So now let's see here. So 0, 1, and how does okay, here it says here, right, the binary numbers, in order we normally read numbers. In other words, we normally read binary numbers left to right, as we do with decimal number, not left to right. On the other hand, commonly taught is multiplying decimal on the Okay, so why is binary read from? Let's see here. Binary, where do we binary numbers? 0 and 1. Okay, whatever. So you guys got the idea here, right? The numbers we have is it's written from right to left here because this is how it's going here. Okay, so let's move on and let's go to our second number, 168, right? 168, and I'm gonna copy this box again. So our 168, let's see what is that number gonna be. So 168, let's do a subtraction here. 168 minus 128. So that is something we could deduct from 168. So how much is left is 40 is left. 40 is left. Can you remove 40 out of 64? 64 out of 40? You cannot. So this part is going to be 0. This part. So this is 1 because we are able to do subtraction here, and this part is 0. So now the 40 is carrying over here. Okay, so 40 got carried over here. So are you able to remove 32 out of from 40? Yes, we are able to remove it. So it will get plus 1 there. So that box is on. 0 is on and 1 is off. I'm sorry, 0 is off, 1 is on. Okay, so let's move to the next box. How much is left here is 8 is left, right? 8 minus 16. So you're not able to remove anything out of it. So this part becomes 0. Okay, then 8 minus 8, you are able to remove something out of it. So 0. And this part is 0 minus 4. You cannot do that. So this will become 0. And 0 minus 2. And 0 minus 1. So you cannot do this. So 0 and 0. So our number here is going to be 1, 0, 1, followed by another 5 zeros. Okay, so 168 is this puppy here. Okay, so now what is our next number is 56. 56. So I'm going to copy this box here again. And I'm going to empty this out. So now what we have is 56 here, right? Can we delete anything out or remove out of 56 out of 128? We cannot. So this part will be 0. Okay, so the 56 still carries over. 56 minus 64. So we're not able to do that. So this becomes 0 here. 56 minus 32. So we can do that. So how much is left is 4 and 2, so 24 is left. 24 minus 16. Are we able to do that? Yes. So that one becomes 1. Okay, how much is left? 8 minus 8. We were able to, so now what is left is 0 minus 4, 0 minus 2, 0 minus 1. So all this becomes zeros, right? 0, 0, 0. So our number 56 to the computer, this is how it writes: 0, 0, 1, 1, 1, then another 3 zeros.
For the 168 above, where you did 8 minus 8, there would be a 1 there, right?
Where?
The one above for 168. There'd be a 1 for minus 8, right?
8 minus 8 would be 1 here, right?
Yes.
Yeah, there would be 1 here. So let's see here, what position was that? Is this position here. Yeah, 1. All right, so what our last number is 100, 108, 108, and I'm going to copy this box again. And I'm gonna delete this, and I have 108 minus 128. That's not possible, so let's go to the next one. I'm gonna carry over 108 minus 64. Okay, so this is possible. I put 1 there. So how much is left here is 44 is left, right? Yeah, minus 32. This is possible. So, and so how much is left is 12 is left, right? 44 minus 32 is 12, 16. So I cannot do 16 here. So this part will be 0. Okay, and this part will be 1, since 12 minus 8 is possible. So how much is left is 4. So this part will be 1. So 4 minus 4 is going to be 0. And 0 minus 2 is 1 is 0. And 0 minus 1 is 0 also. So our 108 is 0, 1, 1, 0, 1, 1, 0, 0. Okay, so that's how you arrive at here. So to the computer, 192 is going to look like this. So to the system, 192 will be this number here. So this is how the computer manages the numbers. Okay, so in here, if you look at this, our binary, even your English letters A, B, C, D, all those are. So all those have their own binary numbers to it. So if you look at the character map, there is a character map. If you bring up character map here, so you have all this now, everything is here. So advanced view, And if you click on something like our favorite, let's see this one here, right? Okay, so all this has so does it have okay, so all these numbers in the background, they will have let's see if it's gonna show us. So this one doesn't give us the, okay, so I'm not worried about that here. So deep down in the background, this is what the system writes. It understands only 0 and 1, that's it, nothing else. So if I do this here, if I paste this in binary, okay, so let's match this up here with the number we got. So if we match this number up, what we have here is so 0, 1, 1 followed by this many zeros. Okay, we're looking good here. Then 1, 0, 1, 0, 1, 0, 0. So I would encourage to calculate on your own that whatever the IP address you have is, you could use this formula here. So we did arrive pretty accurate here. So use this system to calculate the IP address. Okay, so keep this handy here, this part here, so that you could, whenever you want, you could use this here. Okay, so that's too much information. In reality, you don't need to worry about this much here unless you are into networking. Networking people might need this kind of knowledge in there. But even those, they use some kind of converter to do this here. Why would they need this here? Sometimes instead of masking this here, they would use the IP address. And if instead of using this number, if they use this number here, then it will kind of help them, if it's getting hacked or something, this number might be. So to humans, this number is a little complex, right? Compared to this number 192.68.56, we'll never be able to remember these numbers here. So that's what it is for. So, all right, that's the information you need to know about the IP addresses. So numbers are. So numbers are read from right to left. Okay, so the system 9 comes in the end and then 0 comes in the first. Okay, that's how it works. And these are Arabic numbers. Okay. All right, so let's move from here, gateway. This can prove that, Arabic numbers, and then the system recognizes only Arabic numbers. That's gonna prove that the Arabic is a language of God. You could claim that. Let's take a good 15-minute break, and then we'll come back in 15 minutes. So we'll come back like 1:45. Is that okay?
Sure.
Yeah, okay. Let me pause the recording. Are you back here now?
Yeah.
Okay. Yeah, so let's move forward here. So now let's talk about the gateway. Gateway is nothing but the entry point of the network. So, okay. So if you look at the router, so like every router is especially the home router, it could handle up to it will handle up to 256 devices. Okay, so let's see here, why is that?
Do we just start back up?
I'm sorry, yeah, just starting back up. So if you have like a router here like this one, so a router comes with so many ports here, right? But in reality, you could have like or two. In reality, each router could handle up to 256 256 devices here. So so if you have like a home router, if it's Wi-Fi, it's no problem. But if you want to add like if you want to have like 256 physical devices, then you may want to you have to buy the switch. Okay, so looking at this here, there is a limitation, right? You could have so many ports in here, not more than 256, not more than whatever you see in there, like how many you could see, maybe like 40, 50. But if you want to add another bigger capability, so you have to add a switch here. Okay, so this is a router and a switch. Switch is what? It's nothing but an extension of the ports here. So if you search for switch, so right here, like, so you want to have like you may, if you want like a full utilization of a router, you may want to buy like 2 or 3 switches so that you have a full capability of a router. Okay, so most consumer routers are capable of handling 256 devices. can't copy it. Okay, so this is like a bunch of switches together. So the switch part is you don't have to worry about it because the switch is nothing but just a dummy device. What they're doing is they're just helping the router extend the ports here. So you have like a limited number of ports, and then you could add switch in here. It will extend the ports for you. So let's see here. Router gives out IP addresses to each device connected. Okay, so a total maximum you could have is of 256 IP addresses are available. Okay, and how would that calculate it? 2 to the power of 8 equals 256. Okay, that's how it's calculated. And each router becomes a, so if you have like a two routers on your coming in, if you have a two routers coming in from if you have two routers on the system on your network, then you will have two it will become a subnetwork. Becomes a subnet. Okay, what is a subnet? Is a small network in itself. And in there, one IP is reserved for router itself. So the one IP is reserved for router itself, okay? And then so this reserved IP is entry point for the network, entry point for network to communicate with other networks. Okay? Okay, so that is that. So let's see here.
A question.
Yeah.
About the router. So there are like whatever 24, 48
Ports, yeah.
yeah, the ports in there, and then so what is the difference between a router giving out IP address and then you connecting a device directly to it?
So this router this router has an operating system in it. Uh, if it's a Cisco router, it has a Cisco. I mean, when you log into the router here, so you are able to log into the router. You cannot log into the. So if I type the 10.0.1.1, I think this is the. Um, so if you look at this here, if you do on IP config, right, and you see a default gateway is the router for your router here, but I'm on a different network here, so let me bring up. So this is a real network here. So if I do IP config, so this is the default gateway for my Comcast router here. So if I go in here, then I'm able to connect to Comcast 10.0.10.0.1. Okay, so I'm able to log in there, and it says gateway here, right? So this is what the gateway is. So any router by default is able to so connect wireless or not wireless. You should be able to manage 256. So this router I have here, it will allow me to connect to about 256 devices. Okay, that's the maximum. So in that, one IP is reserved. So the reason we have switch here, I'm showing you switch here, is because it's, if you want to have like plugged in, if you want to plug it in, you want to have a switch in there.
Okay.
So when you're building a rack, right, at CDWs, there is a switch in there, right?
Yeah.
That is more than likely that is not a router, because how many servers a rack is holding? Like usually 10 or 12.
It has like 42 U's, I think.
42 servers?
No, it has like, we don't put all of the servers in. A lot of times we just do the cabling, and then it just goes out. And I think they put their own servers. And if they have to put the servers in and get it ready, it's usually the morning shift that does it. So I don't get to do a lot of like software side of it.
Yeah.
Yeah.
Okay, so you know the switch, right? How many ports the switch has?
It could be different. And a lot of times I can't even tell like which one is switch and which one is a router. So
No, more than likely, it has switch in it. It doesn't have a router.
Right, it has a KVM
and a switch, because all those connect to the KVM, and then
KVM. Yes, in the bottom usually.
Yeah, so one cable. So I'm saying it could handle 256 servers. That means that rack is not able. That rack definitely doesn't have 256 physical servers, right?
Right.
Yeah. So what is going to happen there is there will be, each rack will have like switch in there, and then a standard switch is usually 24 or 48. So even though those ports are not being used, they just put like I'm thinking they would put the smallest one would be 24, just to be on a safe side.
Right. So like I was thinking like at home situation, like when you have AT&T or Xfinity router at your home, and then it has like 2 or 3 or 4 ports, and then you connect some of the devices wirelessly, but you could also use a patch cable to connect something. So what is the difference between those two? It's still when you connect something directly using a patch cable.
Yeah, between wireless and wired, the maximum it gives you is 256.
Oh, so all of them included.
Yeah.
Oh, okay.
But if you have like 10 physical servers and your router has only 4 ports, so most of the time routers has only 4 ports, right?
Mm-hmm.
Then you have to buy another switch here. So you could buy like, I have like a 16 port home switch. 16 port switch. So I have one of this switch here right now. So one cable connects to the router, and then all of a sudden all this switch becomes active. All the switch will be part. It will, so the router will all of a sudden have all these ports in there. So instead of 4 ports, when the moment you attach a switch to the router, voila, the router has those additional ports now.
Like an extension.
Yeah, like an extension. So the ports on the switch is managed by the router. So the switch is just sitting there and helping the hardware. It's just the hardware.
Okay.
This is just the extension. All the hard work is done by the router or the cable modem or whatever. If you have like a router built into cable modem, then that's what it is.
Okay.
So now, yeah, that's what it is. So one IP is reserved for. So that IP is called, the reserved IP is referred to as a default gateway. Okay, so if you look in here, if I type which net stack, okay, it's not installed on this system here because we are running a bare bone operating system here. We didn't have like the upgraded one here. It will have all the utilities in there. Let's see. Okay, so NetStat is not in there. So you could install yum provides NetStat, and you could go online and see yum provides. So I think NetStat is part of utils, right? Yum provides so let's see here. If you turn on the one which is like the upgraded one here, it will have all that things here. So, but we don't want that. Okay, net tools. It's part of net tools. Okay, so so now if I do netstat -rn, and it tells me that this is the gateway I have here. So my gateway is 10.0.2.1. And then bound 0, these are not the gateway here. So why is this gateway here is showing you the gateway? Because this is coming in from the NAT gateway. I don't want to confuse you here about talking about NAT. So for the system I have on the another system, netstat-rn. Okay, so E over here also is showing you the gateway is 10.0.2.1. So is 10.0.2.1. Now if I look at my Comcast modem here, gateway, connection status, so that is the IP address, that's the local IP address 10.0.1.1. to get into the box itself. So this is the public IP address. Okay, so let's see, Xfinity network. It is not showing. Ten dot zero dot zero dot two, right? Let's see here. 10.0.2.1. So that 10.0.2.1 is actually coming from here. There you go, 10.0.2.0. Okay, and then the gateway will be 10.0.2.1 here. So there is one more place we could take a look. So 10.0.2. So that's the destination for NAT 09, 10.0.2.1. So if I do IPA 10.0.2.7. Okay, so yeah, the information is right. the gateway is 10.0.2.1 for the NAT network we got here. So the CIDR is giving you a different, this is more into the complex networking here, so I'm not worried about that. So the only thing you have to worry about is the IP address that the router gives out. It's also called a gateway. Let me see if there is another command. Okay, so it is default via 10.0.2.1 and then it's going to pass over from here 10.2.0. Okay, all right, so let me clear this. Okay, so now we'll talk about ports. So port is nothing but a connection. Connection on which application is connected to another device. Okay, I'm busy in the class. Okay, close the door. Okay, so we all know port is what? Just like a port, a shipping port, whatever, that's where you dock. So the connection, if you are connecting using a SSH, what is the port you're going to use? 22. So like here, if you're going to use SSH connection, the default is 22. If you're going to use serial, the default port is 5600. Our login 513. So it's randomly using ports here, but there is a general knowledge that these ports are usually reserved ports. So how many ports operating system has?
Over 65,000.
Yeah, very good, very good. So operating system has 2 to the power of uh, I think you do 2 to the power of 2 to the power of 7, 8, 9. Let's do 8. Okay, that's not good. Power of 9. Oh, not that number. So 2 to the power of 9. Let's do 9. No. Okay, so 2 to the power of 2 to the power of I think 16. 2 to the power of 1, 6. There you go. 65,536. So they are 65,536 places that a network, a computer system could get hacked. There are 65,536 reasons that a computer could get hacked. This is for ports on OS, so either Linux or Windows. They both have 65,536 ports. Out of that, we are not using all of them. Generally, most of them are closed. Unless you install like some specific application, then it will open the port for you, okay? So let's Google commonly used ports. So HTTP is using port 80 in SSL 993, and so let's see here. Okay, yeah, this looks good to me.
Are you in class?
I can be.
Can you take us to Patel?
I'm in class right now.
Can you take us to Patel?
We'll think about it.
Or are you too busy?
We'll think about it. I'm busy right now. I have another half hour. Okay, so let me. So secure shell is used that way. Okay. And this is telnet. And SMTP is the mail. And DNS uses port 53. And these are pretty commonly used, so I'm going to put it together here. And postfix protocol 110 and 119. Right now, don't worry about this here. The only one we're going to be worried about is port 53, which is going to be DNS a little later on when we set up a DNS in ICMP IMAP. Okay, so this looks good to me. And okay, so this is some information here, but here's the thing here. What if you download some application like Skype? You could do Skype port number, and you see like, oh, okay, the Skype is gonna run on these numbers here or these ports. Okay, if it's UDP. What about something like iMessages? So if you want to block iMessages on your Mac, you could block port 5223. Okay, what else? Like WebEx. If you want to block WebEx on your port here 9000, so port 9000 is being used here. So if you bring up the firewall, so I use Windows Defender pretty good. So if you look in here in advanced settings, allow app through the firewall. So these are all the things here. Oh, I got a candy cane here. Somebody's using. I'm going to block that. So if you look down here, there must be iPhone I didn't even know I have all this here. Let's look for WebEx. It's not showing up here. Maybe it says a Cisco. Okay, look here. If I block these ports here, you will never be able to never be able to connect to that system here. So let's see here. So I'm not sure what is it. I thought the WebEx will be listed here, but it's not listed. Maybe its name is something else.
Can you describe the difference between what happens with private and public? Which ones you check out?
Public, if you do public, you won't be able to go on internet, and a private would be in your local area network. Local network would be connecting to another system within your router, home router. So like here, if you have like two computers here, right? I have something called RDP. I have a bunch of computers here. I do RDP, right? I connect from one computer to another computer using RDP. So you might know. So what you could do is, I have one more system in here. So if I have, let's see, let me go into my one other system. Usually what you should be able to do is go in here and click on your network, and then you could see some network computers on your network here, right? So what you have to do is, if you are connecting, this would be the same as connecting to any other system here. So here, if I do this here, either you could use the name if the DNS is set up. If not, then you could ping it and get the IP address, right? Ping DOMARA 0001. So it's pinging, and that is the IP address. And I know this is on my local network here, right? If I do copy this and paste it in here, you're connecting it locally here. It's going to ask you for the username and password. If I provide that, it's going to recognize this, and then it's going to allow me to connect to the system here. So this is one of my other system I'm connecting remotely here, right? Similarly, you could connect using RDP anywhere in the world here. So if I connect locally, that means that's a private network. And if I'm running on a public network, that means if I'm connecting outside your house, then that is a public network. Where did it go? Not this. So private is, you could do it privately, or you could do it outside the network. So I think I have one other IP address here. You should be familiar with this, right, Adil? Doing a RDP.
Yeah, I know a little bit.
Like I have one other server sitting remotely outside my house, and the IP address was 54. So most of the time the private network starts with 192 or 10 or 172. So I have this remote server here. Look at this IP address. It looks totally random, right? Not the one you are familiar with, 192 or whatever. I think the IP address has changed. So I'm going to connect to that assignment server. This is the IP address I have it for there. It's not connecting. But anyway, you got the idea, right? The public is going outside the network and private is within the network. So those 256 devices, they could start communicating with each other, provided you have a router here, okay? Router is also facilitating itself as a network here. So when I say subnet, over here I said subnet here, right? It's actually a network in itself. That's what it's called, subnet, small network. So now let's move beyond this here. Let's understand what is the commonly used ports. Okay, so here's the other thing. Let's talk about the IP address class. So let's look at our IP address here, right? What is our IP address? So we have here IP address, but so let's understand each IP address belongs to a subnet, okay? So in here there are 4 subnets. There are 4 subnet information in each IP address. So let's take a look at this here. So here here I'll say like 1, 2, 3, 4. So this is okay, so we got this IP address here, right? So let's break this down here. So each block, so we are at 192. Why are we only restricted to 192?
It's class A or B or something like that.
Yeah. So, but remember, so now we're gonna go back and relate this here. So each subnet could hold a maximum of, don't get confused here, the subnet is IP address octet. IP address octet is a 2 to the power of 8, okay, and the subnet is 2 to the power of 9 octets. So if you do 2 to the power of 8, then you get, what is the 2 to the power of 8? So this is what it is. 2 to the power of 8 is 56. Okay, here I said total number of maximum IP address available in each class is 256, okay? But generally speaking, I didn't mention class here. Generally speaking, if you go by a router, it's gonna be maximum of 256. Okay, now let's work on this here. So if I copy this, copy here, this is how it's working here. And this, if I do this here, so this is 256, 256, 256, 256, okay? And the starting point is 0, 0, 0, 0. So now if I so this is 0. If you multiply all 4 zeros, what is going to be? 0 times 0 times 0 times 0 equals, still is going to be 0. It's going to be 0. Okay, good. Now above here is different here. 256 times 256 times 256 times 256, okay? So what is going to happen here is what I'll do is I'll cut this part out and I'll put it down here, okay, so that you don't get confused. So go ahead and do the multiplication. What is the number you're getting? 256.256. Give me the number. I know this is 0. What is the number here?
4294967,296. So 42 billion. Is that right?
429. Give me the number. 4294.
967
967
296.
296. So no, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it's actually 4 billion. 4 billion. 294 million 967,000. This is the maximum number of IP addresses in the world for class A IP address, class 4 IP address. It's called IP version 4. IPv4 version 4. And this is the minimum it starts from. So we already have exhausted IPv4 IP addresses here. So they cannot go maximum of 4 billion here. Okay? So now if you have like a subnet which is 0.0.0.0, so how many are available? Because all this is 0. So if your IP address is starting from 0.0.0.1, so how many IP addresses you think you have available here?
1.
Okay, so for that, let's see here. So if this is 1 here, right? So let's see here, 0.0.0.1. That means in binary, what would it be in binary? I have to go backwards here. So let's see here. If I am doing IP address classes. You don't really need to worry about this too much, but if you're going to be a network admin, then you would. So there are 4 classes of class A, B, and C. Okay, so let's look at this chart here. It looks good chart. Okay. So if you're starting from the zero, if you're starting all zeros are there, and this is what the binary would look like. Okay, and you would have 4 billion, about 4 billion IP addresses available to you. Okay, that is not possible for individuals or organization, but that's how it's categorized. /0 IP address /0, that means you have you have a capacity of that many IP addresses, 2 to the power of 32. /1 means 128. Okay, so this like 1 0 0 0 0, everything 0, so 128, right? So if we go back to our formula, our formula is starting here from 128. So the way, if we have like 1 in here without any subtracting anything, 1 in here, that means this part will become automatically 128. So if it starts from 128, so /128, then it has followed by 3 zeros here. So 1, and all these are zeros here. That means you're getting a 2 billion 100 and there are many IPs in that class subnet. Okay, that's not possible either. It is possible to set up one network here, but it requires like every country working together on it. /2 is getting half again. This is where it's starting to 192. And these are 1 billion is available, 2 to the power of 30. So all this is coming up down here. And most of the time, we are working on /24. And the maximum each network is allowed to have is 256, okay? There used to be, is there a 172? No. So we normally will you will be playing around /24 here. Now if you do IPA, you see /24 here, right? Now this makes sense here. Why is he showing /24? Almost every time, I've been working for 20 years, so I never seen anything other than 24. Okay, so most of the time you don't have to worry about it. You will be just dealing with /24, and you have about 256 IP addresses in there. If you want more, you just have to keep adding more network adapters. Not network adapters, I mean routers.
What's the scope? They talk about like extending the scope or something like that.
Yeah, you have to jump to IP6. IP6 is unlimited almost here. IPv4 is 10 to the power of 2 to the power of 32. Okay. So the maximum is so all this will come out to 2 to the power of 32. If you do a math here, 2 to the power of if you just simply type 32, that's what it's gonna 4 billion to 4 billion, all that number. Okay, I'm not gonna say that. So the IPv4 is a maximum. So 2 to the power of 32 is the ceiling here. When the networking was invented in 1969, that's the number here. Nobody thought it would be all exhausted within 40 years. It did. So that's why you have the IP address here. So on your cell phone, you could find out the IP address for anybody, public IP address, right? So if you do like what is my IP, whatismyip.com, you go there, it will tell you that this is your IP address here, right? 73 and all that. That's what is coming here. But if you do the same thing, turn on your cell phone, turn off Wi-Fi, and then do what is my IP, it will more than likely it will give you IPv6. IPv6 will give you like an alphanumeric number here. Okay, so let's take a look at that. So most of the time, the home computers, they would have IPv4, IPv6. So in here, I think our system is showing IPv6 too. Yeah, this is IPv6. It's running on 64-bit. Ours is 2 to the power of 32, and this is 2 to the power of 64. So let's do that. 2 to the power of 64. I'm not sure if that is right though, but okay, don't. Let's see how many IPs. Oh, okay, 2 to the power of 128, so 342 trillion. So you do 2 to the power of 128. That's the full number here. I mean, it's not showing the full number. It is supposed to show you the full number, right? Why is it not showing? Because trillion will be way too big. Billion is big enough already. Trillion.
Maybe too many zeros for it to hold.
Yeah. So that's why if you look at the IPv6 sample address, and this is the IPv6 address here. I'm not even going to go in there. I mean, the whole world is trying to push towards IPv6, but it's not happening fast enough here. So this is actually the IPv6 address. There is a void in here. Though if you do like 2 semicolons here, there's a void in there, void, because there's number is not available here. But this is not true IPv6. If you do it on your cell phone, turn off the IP and then do the what is my IP, it's gonna give you the IPv6 number here. So let me copy this and put it in. Okay. I wanted to calculate the number. Let's see if it's gonna do it. Yeah, it's not doing it. So I did my IP address here. So this is the IP address of my cell phone, okay? This is the IPv6 address. So it has 1, 2, 3, 4, 5, 6, 7, 8. So instead of 4 octet, this one has 8 octet in it. Okay, here's what is showing here. Link local address, unique, I don't know. Actually, I had found this in my previous class here. This is what the number looks like. IPv6. This is 3 trillion. Okay, that's enough of that. So we'll leave it there. Okay, so tomorrow I have a plumber coming in tomorrow, so I may not have a class tomorrow. But I will let you know for sure, okay? If the class is going to be there or not. I'll let you know as the earliest I could, maybe like I'll try to let you know by 11.
Okay.
Okay, so well, hopefully I don't want to miss it, but if he's here, then I have to be with him. So we'll see how it goes. All right, so we'll have some class this Thursday, and then it's up in air what time. I'll put it in the chat. And Friday is there too, so Thursday, Friday. Actually, I'm working Thursdays, so but I still want to help you guys out. Friday is off, so if you could decide, and because not too many people are joining, so just you two guys. What time, whatever works, then I'll log in and I'll help out. Okay, any questions? Put it in a chat, and then I'll go from there.
Okay.